Well, as you can see, I've got Matlab open. Today we're going to be looking at using Matlab to curve fit and analyze some data from our pendulum experiment. First, we need to go ahead and type in our data. We'll first type in the length and then the period. So I'm going to create a variable here, length. Please notice the use of the square brackets, and now I'll just go ahead and type in the data points. Notice between each data point I am placing a space. Also notice the data does not have to be in any particular order. However, the period and the lengths of the pendulum should match up. So I've got the length data typed in. Notice at the very end I type a semicolon. This merely just keeps Matlab from spitting that line back out at me again. So it's just sort of a way to prevent some unnecessary clutter on the screen. It's not particularly important. So I've created my length variable, as you can see right over here in the workspace. Next will be the period. One thing that's very important is the number of data points in both the length and the period need to be the exact same number. Okay. So I've now entered in my data. If you have only a few data points, as we do here, it's appropriate to go ahead and type them in. Otherwise, and this will be part of the next video I make, we'll go ahead and use Matlab's ability to actually import data. But for right now, we'll just type it in. I'm going to come up here to the apps button. I'm going to click on that. Then I'm going to click on the curve fitting. And that's going to bring up a user interface. First thing I'm going to do is I'm going to change the name of my fit to pendulum. This should fit whatever experiment you happen to be doing. On the x-axis, I'm going to select length. On the y-axis, I'm going to select period. Over here on the curve fit, I'm going to select power. I'm only going to have select power. There we go. Just going to have one term here. Notice over here our A term is 1.657, which will actually round up to 2. And the B term, which represents the power that things are raised to, is 0.4166. That actually would round up to 0.5 since we're actually taking a square root. I've got curve fitted my data. The next thing I need to do is I need to actually export the fit to our workspace so we can continue over in Matlab. So I'm going to choose fit. Sorry about that. I'm going to choose fit and then save to workspace. It's going to give me these things. You can change these. I tend to just leave them as they are. And we'll see what each one contains in a moment. The other thing I'm going to be doing is this information here we're actually going to include in our final graph. So we don't want to close out the curve fitting just yet. So we'll just come down here and come back over to the actual Matlab window. Now if I just type in fitted model, Notice it tells me that it's a power fit. It gives me the equation, gives me the coefficients. If I type in goodness, notice I get the R square error, adjusted R squared error, root mean square error. Teacher will talk about these in class, but this tells us how close our fit and data are going to be to each other. All right. First thing we want to do is we actually want to plot the fitted model and our data on the same graph. Very easy command. We just type in plot, fitted model. Notice that we get some help from Matlab in terms of, where you put the coordinates. In this case, we always go X, then Y. But first we'll just type in fitted model. And then we're going to type in the data with the X coordinate first. And we'll hit enter. Notice we get a graph coming up here. The fitted curve is in red. The data is right there as our data points. We have the X and a Y label on our axis. We're going to go ahead and change that eventually, but that's what's there. Okay. So then we'll come back up here. I'd like to see a grid, so turn the grid on. And if I take a look at that graph again, notice we have our grid lines. Next, since we want to plot a few other things on top of this, we're going to tell the computer to put everything on the same graph. So we'll type in hold on. Notice, sorry about that. Notice we just type in hold space on. So that's done. Next, we're going to call our program for error bars, which is just error bar 1. The X data comes first, and then the Y data, as you can see down there in the little help thing. So that's just going to be length, comma, period. And then we'll hit enter. Again, if I take a quick look at our figure here, notice I've now got the error bars. Our data is inside of the circles. In this case, I've used a standard error calculation. Again, not a big deal for what we're going to be doing in 300 physics, just more of a point of reference. We need to go ahead now and put labels on the x-axis, the y-axis, the title, and we'll add some sort of a legend. So for the x-axis, we type in x label. We have to put this inside of a single quote, and that's going to be the length with the units, which are going to be meters. We close the quote, close the parenthesis. We'll then type in y label. And we'll give our plot a title. Pendulum experiment. Finally, we'll add our legend. First thing that'll come up will be our data. Then we have the power fit. Followed by the error bars. So let's take a look at our graph. So if I take a look at our graph here, notice we have, there's our legend with the data, power fit, and the error bars. Here's the graph, okay? Our length, and our period are right there. Now, as I said before, we need to put some other information in here, which is the type of fit we have and the coefficients. Those are always good things to show up on the graph, though you could have them underneath the graph as part of, say, a lab report. So we'll go back to the curve fitting tool, which is right down here. I'll merely come up here and highlight that. On Windows I use a Control-C, but you just want to copy it. So we'll copy that information, pop over here to the figure. I'm going to make this full screen so I've got plenty of space to work on. We're now going to come over here to our tools. We're going to select Edit Plot. We're going to insert text box. I'm going to draw my text box, and then I'm going to paste in the information that I was given. Now, a couple of things we want to do here. First, I'm going to use the font editor, so I just right-clicked inside the box there. I'm going to change this to, say, a 14 font, make it bold. It's a little easier to see. Okay. And next, I'm going to, again, click in this box, and I'm not going to have any line style around my text box. Next, I notice my axis labels here need to be a little bit nicer, a little bit bigger so we can see them. So we just click on them, we'll select the font tool. We can make them, say, a 24 font bold, nice and big. We'll do that for both axes. 24 font, make it bold. We'll do the same thing with the title. This will make it a little bit bigger. I'll say a 36 bold. There we go. So we've got everything. We've got periods so we can see it. We've got the information about the type of plot we have. You can come in here, and if you need to want to rearrange how things are put in a little bit, you can go ahead and do that. Next thing we have to do is come up here and click on our tools again, click on the Edit Plot, and our plot is now good to go. You can then come up here to File, and we can do a Save As, and we can choose JPEG or bitmap. Well, I'll go ahead and choose a JPEG, and I'll put this probably on my desktop, but you can put it anywhere you want. We'll just give it a name, Pendulum, and I'll put it on the desktop, so we'll save that there. So we'll go take a real quick look at that. So there it was, saving the picture. So just minimize everything here, and where did it go? Sometimes might be better putting it in a folder, but that's okay. I think I'm going to try that save one more time because I don't see where I put it. Ah, there it is. If we open it up, there's the graph. And notice our plot is complete. We can put that into a Word document. We can put that into PowerPoint, and that's it. Good luck plotting.